Welcome to 13-4 video lesson underneath Algebra 2, and it's all about the sine function, and there are 8 boxes for us to talk about. So kind of a lot for us to do, so we want to make sure that we got all this stuff down here. Okay, box number 1, we're going to talk about where does the sine curve come from. Okay, where does it come from? So on the left hand side I have the unit circle for you, and along the unit circle I have a couple of key points. All right, so I have at this point here at 0 radians I have the point 1 comma 0. At pi over 4, from the last lesson we learned the exact value for sines and cosines. Rad 2 over 2, rad 2 over 2. Up here I have the point 0 comma 1 right there, and then I can so on and so forth all the way around the circle. Okay, now we also know that the sine curve only deals with the y values. So if I look at all of the y values only, that's what I'm going to concentrate on. So if I highlight all the y values, so it goes x comma y, so that's a y value, that's a y value, that's a y value, 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 and a y value. Remember, the sine curve, or we know that the sine function deals with the y values. Okay, so as I travel around the circle, I have different degrees or different radians, right? And then I have different values at each point. So what I'm going to do is I'm basically just going to unwrap the unit circle onto a new coordinate plane where the x-axis is going to be my angle theta, and the y-axis is going to be the sine of theta. So all I'm doing is comparing theta to sine theta. So here we go. Let me see if I can make this clear for you. At 0 radians, the y value is worth 0. So 0 comma 0 has to be on this point over here. Okay? At pi radians, which is right up here, 90 degrees is the same thing as pi radians, the y value is worth 1. So at pi, it has to be worth 1. Okay, perfect. Oh, sorry, this is pi over 2. Excuse me, this is pi over 2. And then this is pi, my bad. So at pi over 2, I'm up here at 1. Okay? At pi, the y coordinate is 0 again. So I'm back here and here at pi comma 0. At 3 pi over 2, which is this one over here, 3 pi over 2, the y coordinate is worth -1. So 3 pi over 2 comma -1 is going to be a coordinate on the new one. And then finally, if I go all the way back around to 2 pi radians, which is all the way around, I'm back to 0 again. So if I connected all of these points with a smooth curve, I would see that I would get this periodic function, and that is where the sine curve comes from. All we do is we take all the y coordinates on the unit circle and we spread them out onto a new axis where we're comparing theta to the sine of theta, and these 5 dots are the ones that we're going to use to sketch the sine curve every single time. So that was box number 1. We now know where the sine curve comes from. Okay, here's box number 2. We're going to estimate the sine values graphically. And what I have for you is a nice, beautiful picture drawn from Desmos, where the x-axis is your radians, so I'll call it your theta, and then your y-axis is the sine of theta. So this curve right here is the beautiful, nice, awesome, perfect sine curve drawn for you by Desmos. So again, we have 0, 0. The sine of 0 is 0. The sine of pi over 2 is 1. The sine of pi is 0. The sine of 3 pi over 2 radians is -1. And then, of course, the sine of 2 pi is 0 again. So how could we use this to estimate the sine of 2? What does that mean? That's saying the sine of 2 radians. Now remember, you guys, pi is 3.14. So 3.14 is here. Remember, pi over 2 is half of that. So 2 would be somewhere right about here, I'm guessing. Okay, that's about 2. So if I look up on the sine curve and I look over, I get close to about 1. So I'm going to say this is about 0.9 or so. Okay, the sine of pi, well, that one is easy. It's right here. It's at 0. So the sine of pi is going to be approximately 0. And then the sine of 3 pi over 2 is down here. Here's 3 pi over 2. If I look back, I'm getting a value of equal to -1. So you can actually check this on the calculator as well, team. So if I turn my calculator on and I check the mode to make sure that I am in radian mode, because I'm asking the calculator for the sine of 2 radians, I should be good to go. So check this out. If I say sine of 2 radians, I would expect to see about 0.9. And look, I get 0.90929, blah, 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 blah. If I ask the calculator for the sine of pi, I could say second pi, which is that caret button. I'm asking the calculator for the sine of pi radians, and I should get 0 back, and of course, yes, I do. I could also ask the calculator for the sine of 3 pi divided by 2 radians, and I should get the answer of -1, and I do. So your calculator can do this as well, but I wanted you to match it to the graph and see where all these values come from. Okay, box number 3 is asking, what is the period of the sine curve? So you should have put together that sine curves are periodic functions, meaning that they have repeated y values as x moves along the axis. So what is the period of the sine function? So check this out. I'm going to start here, okay? And I'm going to trace out the sine function until I get back to that spot again. So there it is right there. All right, so what we have just realized in this picture is that the period is worth 2 pi, and we measure it in terms of radians because that is the scale of our graph. Our x-axis is radians, our y-axis is the sine of that radian. So the period for the sine curve is now equal to 2 pi radians. Okay? So the period is 2 pi radians. That means it takes a distance of 2 pi to complete one full cycle. So we want to commit this to memory. Okay, box number 4 is a very, very important box in terms of showing you how to come up with the periods for different sine curves. So I'm going to show you 3 different sine curves. The first one is in black here is just the regular old sine curve, and we can clearly trace out the period, and that period is worth 2 pi. So remember again, the period is the distance it takes to complete one full cycle, and that would be 2 pi. Okay, so let's compare that to this blue graph down here, and the equation for the blue graph is y equals the sine of 2 theta. So notice that I have the 2 highlighted for you. So how does that change the graph? Well, again, we can still just trace out one cycle until I get all the way back, and check it out. My period has now shrunk to a period of pi radians. So a lot of people ask, what does the 2 mean? Well, the 2 means that I will have exactly 2 full cycles of the sine curve on a distance of 0 to 2 pi. So that's what that means right there. So if I look at my regular 2 pi, I will have one, so you can kind of see like this is one cycle right here, and then of course the other cycle is right here. So the 2 in the equation here means that I'm going to have 2 cycles on a normal sine curve, but the period in this particular case, the period is worth pi radians, okay? So one way that we can come up with this answer is if we take 2 pi and we divide out the number that's in our equation, which is 2. Notice I get a value of pi, and that tells me the period of this particular sine curve. So why did I take 2 pi and divide it by 2? Because the original period for the sine curve is worth 2 pi. So we're taking the original amount and we're dividing it by the number that's in between the sine and your theta. Let's do another example here. See this green graph here? This green graph is the equation of y equals the sine of 4 theta. So again, I'm going to do the same exact thing. I'm just going to trace it out on my pen. So I'm going to start there and come back, and I'm noticing that I complete one full cycle of the sine curve on a distance of pi over 2 radians. So what does the 4 mean? Well, the 4 means that I'm going to have 4 of these on a distance of 2 pi. So you can see it 1, 2, 3, 4. So if I chop this graph up, I get 4 full sine curves on a distance of pi over 2. Another way we can come up with this, similarly, is if we took, I'll do green for you, if we took 2 pi, which is the original period for a sine curve, and divided it by that value that's in my function 4, notice I would get a value of pi divided by 2, and that value tells me exactly what one period is worth. So box number 4 is a very important graph in terms of showing you how to come up with the periods for different sine curves. So there's a nice picture of all of them together. Okay, box number 5 is a U-try. I want you to determine the period for the graph of y equals 6 theta, and I have given you a nicely graphed Desmos picture down below for your added convenience. So what is the period for sine of 6 theta? Okay, so what I did was I traced one of my sine curves out until I got back to my starting point. It's kind of hard to see where that is. I know it's smaller than pi over 2, so what do? I took the original 2 pi, the original period of the sine function, and I divided it by the number 6, which is that number that's in between my sine and my theta, and I got 2 pi over 6, which gives me pi over 3. So what that means is that the period now is pi over 3 radians, and the 6 means that I'm going to have 6 of these on a distance of 0 to 2 pi. So hopefully you got that right. Okay, let's compare amplitudes for different sine curves. So the first one is the general old sine of theta, and again we have our nice little 5 dots here that we could use to draw the sine curve. So there's one full period of the sine curve. And remember that the amplitude is the distance from the midline to the high and to the low point. So if I draw my midline and I look up, or I draw my midline and I look down, I have a value of 1. So the amplitude for a generic sine curve is equal to 1. And that's just 1 unit. That's it. The amplitude is worth 1. Okay, let's take a look at this graph that I have here. I have 2 for you. The black dotted line is sine of theta, and the blue dotted line is the equation y equals 2 times the sine of theta. So notice that the 2 is now on the outside or in front of the sine theta. Notice it's not in between the sine and the theta itself. That means it's going to be an amplitude adjustment. So again, here we go. I'm going to draw my midline, and I'm going to go up to the highest point and down to the lowest point, and I'm going to calculate and see that, oh my gosh, it's worth 2. So this number right here tells me what that amplitude is. Oh, very, very cool. Okay, let's do one more example here. Check out this green graph. The green graph is y equals 4 sine of theta, and the black graph, of course, is y equals regular sine of theta. So again, if I'm looking for the amplitude, I would draw the midline, and then I would draw my point up to the highest and look over, and then drop to the lowest and look over, and I'm seeing that that value is worth 4. So again, the amplitude of this graph is worth 4. Very, very cool. Okay, one more for you. This one's kind of a trickster one. So the black one is the sine theta, and the red one is -1 times the sine of theta, but we don't write it like that. Instead, what we do is we write it as negative sine theta. So you could see that in this case, if I draw my midline and I go down and I go up, notice that I still have an amplitude of 1, but that a negative in front is going to flip the graph over the x-axis. So it is a reflection over the x-axis or the theta axis, depending on how you're looking at it. Okay, so amplitude is that number that comes out in front. A negative is going to reflect it over. Other than that, it's just pretty straightforward. The number out in front tells you what that amplitude actually is. Okay, box number 7 is an example. We are going to sketch the graph of y equals 3 times the sine of 2 theta for 0 to 2 pi. So that means just on the interval from 0 to 2 pi. Okay, so I'm going to do this in green for you. The first thing I want to do is figure out my period. Okay, the way that I figure out my period is I take 2 pi and I divide it by the number that's in between the sine and the theta. So I get 2 pi divided by 2, so I get a value of pi. Okay, so that means I need to start here and I need to end here, and this has to take up 1 full cycle of the sine curve. So remember, I can draw the sine curve in 5 different points, and so if this is the first point and this is the ending point, then this has to be the midway point. And then this has to be the other midway point, and then finally the other midway point. So I'll show you what I'm doing there for that one. So this right here, right, this has to be my period. So it has to take a distance of pi to complete 1 full cycle. But now I also have to consider the amplitude, right? The amplitude is going to be the number that is sitting outside. So my amplitude is basically an absolute value of 3, which in this case is 3. Okay, so that means that this graph is going to get stretched up to 3 and down to 3. So at the quarter point, I'm all the way up at 3. And at the 3/4 point, I'm all the way down at -3. So I would have this going on right here. So hopefully you see that what I have drawn is I have drawn a sine curve. And I have drawn it in a distance of pi because my period is pi. And my amplitude is now worth 3 units. But it's asking me to draw it from 0 to 2 pi. So I'm going to go ahead and just draw another version of this thing from 0 to 2 pi. And it would look like that, and it would look like this. Since it's periodic, I know that it's just going to repeat itself. So all I have to do is kind of just do like that. And I would just do like a little dashed line to show you that I've actually done what the problem asked me to do. But this one highlighted in green is the important one. Okay, you made it all the way to box number 8. Nice job. It's a you try. Just tell me what is the equation for the following sine curve. So consider the amplitude and consider the period. Okay, here's how I solved it. I knew I needed two things. I needed the period and the amplitude. So what I did was I traced out one section, and I figured out that that is a distance of pi over 2. So I knew that the period had to be a value of pi over 2. But that's not what goes in the equation, because remember, the thing that goes in the equation is 2 pi divided by what number in my equation would give me that value of pi over 2, and that number happens to be 4. So that's how I knew that this was the 4 right here. And it's also to note that the 4 means I'm going to have 4 separate sine curves on a distance from 0 all the way out to 2 pi. So if you can see, I've drawn a blue one, a red one, a green one, and a pink one, and that's what the 4 means. I have 4 full sine curves on a distance from 0 to 2 pi. And then, of course, the other thing was just the amplitude, and the amplitude was easy to find. I just went to the highest point and looked over, so I knew the equation was y equals 2 sine 4x. Okay, nice job, you guys. I know that was a long lesson, but I'm very proud of you.